This will be part 2 of a lecture on practicalities of passive acoustic monitoring, and in this part we'll focus on project design, specifically collecting data and managing those data. This presentation assumes an understanding of the following topics: sampling rate and gain. If these topics are unfamiliar, please watch the Introduction to Digital Audio lecture before proceeding. Here's a brief overview of the topics that we'll cover today. We'll start with the importance of metadata and some strategies for assigning site and hardware ID codes. We'll then talk about recorder setup, deployment sheets and metadata organization, and some programs for transferring files and organizing them. Finally, we'll end with some practical suggestions and lessons learned that were shared by our staff. So beginning with metadata. Metadata is additional non-audio information about when, where, and how an audio file is recorded. And without this metadata, a recording may be useless. You may have this beautiful recording, but if you don't know when it was made or where it was made, it doesn't really give you any information biologically about that site. Metadata failures can be quite common. For example, they might be missing location, or if you don't have appropriate metadata, you might not be able to tell what recording unit was used to make a recording, so that now you just have a pile of 40 recorders, and those were deployed in 40 sites, and one of those didn't work, but you don't know which recorder wasn't working. And so you end up deploying that equipment again, for example. Metadata problems are among the most common and frustrating sources of inefficiency and data loss in PAM projects. So some of the things that might be essential to include in your metadata are the date and time of the recording and the location where it was made. Location can have a few levels of precision. For example, it might refer to a site and also include the information about the state or territory and country, but within a site it can be quite specific, such as an individual tree or latitude-longitude location. There's also a variety of information that might be part of metadata and can make your recordings much more useful. This can include recorder ID so that you can match the particular piece of hardware equipment that made the recording to the recordings, configuration, the gain settings that were used, the sampling rate, information about the type and potentially the age of the microphone, the recording medium, so for example, the ID number of the SD card that's placed into the recording unit to capture the data, people that were involved in the deployment and retrieval in case there are later questions, and other project-specific information. This information, in addition to providing useful context on the recording, can also be very valuable for troubleshooting. Many recording units automatically encode some of this information, particularly the date and time, and the ID information that's stored on a recorder. To keep track of this information, we often use a spreadsheet or even a database to track and manage it. There are examples of these materials in the online folder. The next thing we'll talk about is ways to assign site and hardware ID codes. There's a variety of ways to do this, but there are certainly some that can make your life easier or harder. To imagine why site and hardware ID codes might be useful, let's start by imagining the simplest possible recording design. So in this case, let's say that you have one deployment per season, and you have two sites, Site 01 and Site 02, and in each you place a recording unit, Unit 001 and Unit 002, and you have the latitude and longitude for each of those sites. This is about as straightforward as you can imagine, and relatively easy to keep track of at this point. But let's imagine what happens in year 2. Now when you go back to collect the data at the end of year 1, you discover that one of the units has been damaged, perhaps by an animal, perhaps by water or a tree fall, but fortunately you're prepared for this and you have a backup unit, and you deploy that new unit. So now we still have the original unit in Site 1, but in Site 2 we have a new unit, Unit 003. And so in this case, Unit 003 has never been in the field before, and the microphone is younger and perhaps more sensitive, and there might be some differences in hardware or firmware, depending on when these units were purchased. But this is still a relatively straightforward design. Now let's imagine what happens in year 3. Let's say that we want to record for a longer period of time, perhaps to capture spring and fall dynamics or rainy season and dry season. And so we add an additional deployment. In addition, we discover that the tree that we are using at Site 01 is showing signs of rot, and it looks like it's going to fall in the next year or two. It might have been struck by lightning. For some reason, we need to move that recording unit. And so we pick another nearby tree, but now this is site 03 with slightly different latitude and longitude coordinates. So now we have 2 deployments. There are 3 different total sites that have been used. There are 3 units that are being used, and suddenly if you're trying to do very careful comparisons of recorders that were exactly at the same site or microphones that were exactly the same age, now there's a lot of complexity that very quickly field deployment teams might not remember some of the details of how this was structured. And you can easily imagine how slight details of the recording schedules or deployments might vary. For example, if you decide to add an evening sampling period as well, or something about the schedule is misset during one of the deployments, and you have a sample interval that is missing. So very quickly, even a 2-recorder project can become a pretty complex bookkeeping exercise. So it's good to think about your system going into it and to keep careful notes on how it's maintained. Some of the strategies that we use for this include unique codes that identify the location of each recorder. So for example, SAP01 might be Site 01 in Sapsucker Woods, which surrounds the Cornell Lab of Ornithology, where we're based. We also have unique codes that identify the recording unit, and sometimes this refers to the type of recording hardware that's used. So for example, SW01 might be Swift unit number 1. We found it quite useful to incorporate leading zeros in site and unit names so that the numbering system can expand without increasing the number of characters in the file name. So for example, if you have Swift 01, you can have Swift 10 and Swift 50, and all of those names will be the same length. And that means that whatever computer program you're using, the files are likely to sort in the same order. And if you're using something like R or Python code to parse file names, you can predictably find the unit number in particular character positions. So you might always know that characters 2 through 4 give the Swift number if you're using Swift recorders. It might also be valuable to identify and track microphones through time. Microphones can degrade substantially and lose sensitivity with age, and so if you're running a long-term passive acoustic monitoring project, it's very useful to keep track of your microphones and to replace them regularly, or at least to measure microphone response so that you know what you're actually capturing across time. Strategies for keeping track of microphones can include using things like nail polish to color code the year that a microphone was first deployed. So for example, in 2020, we might put a dot of red on all the microphones that are new that year, and the following year a dot of blue, a dot of yellow, and that way you can quickly look at a microphone and know how long it's been in the field. Or you might find it valuable to track individual microphones, particularly if you're doing detailed measurements like trying to estimate density of populations. And in this case, you can use a multi-dot color code system. So an individual microphone might be denoted by red, red, yellow, blue as its ID code. That allows you to track individual microphones without having to try to write on them or fix a permanent number. You might also consider playing a standard sound or tone series to all units at the beginning and end of the season, at least to have a metric of differences in sensitivity. If you find individual units that are much more or much less sensitive, that can be cause for concern. Even if a project starts relatively simple, know that locations, units, and microphones are likely to change through time. Having unique identifiers makes it much easier to track these changes, and particularly to identify and remove bad equipment. It can also be quite valuable to spot check recording quality after deployments to make sure that you aren't conducting multiple deployments with damaged or defective equipment or with settings that aren't very useful for your project. So for example, if you have a microphone that gets damaged by falling debris or animals, and you just keep using that microphone or recorder year after year and downloading, organizing, and archiving the files without ever looking at them, you might have multiple years where that unit has been deployed and all you're getting is empty files. It's also a good way to make sure that your settings are actually capturing the data and the schedule that you think that they're capturing. Unique codes can also be very useful for the SD cards that are placed in recorders to capture data. There are various ways that SD cards can be named. For example, if they're always used in the same site for long-term monitoring, you might just have an A set and a B set of cards that match that site. So for example, when we're recording around our central building, In Sapsucker Woods, we have Sapsucker Woods Site 1, and there's an A set and a B set of cards for that site. And so when we go to collect data, we take set A out of the recorder and put set B in so the recording can begin immediately. And then we bring set A back to the lab and download and curate those files. And so if the sites are fixed, having just a rotating roster of 2 cards can be quite useful. However, if you're conducting a project that requires you to move units to many sites, it's hard to match cards to a particular site, and instead it might make more sense to match them to a recording unit. And in that case, you may have A cards and B cards that match the unit number. So you might have SD001 that matches recording unit 001 and rotates back and forth in that unit. You might also encounter a scenario or a project where recording units and cards are quite mobile, and you go to a site and you deploy 10 recording units, and into those units you put 10 cards, but they're not always the same 10 cards. For example, if it takes a little while to get some of the cards downloaded, or if some of the cards are out of service, you might just have a pool of cards and a pool of recorders. And in that case, it becomes especially important to make good notes about which card is deployed in which unit and site, because it's very easy to end up with a card that's just SD132, and it's not clear what location it was used in, what time, if you don't have data on the card, whether it was something about the unit or the card. And so because there aren't natural affiliations among cards and units and sites, you have to be very careful to create those in your database. The next thing that we'll talk about is setting up recorders. And one of the most important decisions that has to be made when setting up recorders is what to do about time zones. Some geographic areas have a mid-year time change. So for example, in North America, we observe daylight savings time. This is a huge headache for setting recorder clocks because it means that you're setting the internal clock on the recorder, and then partway through the deployment, the local clocks are changing compared to the clock that's running in your recording units. In addition, large projects may have deployments across multiple time zones, and not all regions or countries even deal with these mid-year time changes in the same way. They might change on different dates, or they may not observe time changes. So we have 2 primary options for dealing with this. One is to set recorders on Greenwich Mean Time, also known as UTC. In this case, all of the units are set on Greenwich Mean Time, and that time doesn't observe any of the daylight savings changes or other time changes through the year. The other option is to record on local standard time, where you completely ignore any mid-year time changes, and all units are just on the standard time in the place of deployment. There are pros and cons to both of these approaches. Recording on local standard time is often more intuitive and easily referenced to dawn, dusk, and other events. Cons of this approach is that it's less standardized, especially across large geographic areas, and it can be error-prone because people will often forget about the daylight savings time offset, either when they're setting up the recordings or when they're looking at the timestamp of the captured recording. Greenwich Mean Time, or UTC, has the advantage of being standardized and consistent, especially across large areas or in polar regions where time zones are small. The con of this approach is that it's not necessarily intuitive for all users, and it requires calculation of a time offset to determine biologically meaningful time. So for example, sunrise might occur at 0300 Greenwich Mean Time, and there are times each day when the calendar date and the Greenwich Mean Time day will differ, because the Greenwich Mean Time will move into a new day differently than the whatever local time zone you're on. It's very important to note that if you decide to deploy on GMT, your recording schedule also has to be on GMT. So if you are offset by 5 hours to Greenwich Mean Time and you want your recording to start 6 hours after dawn in your site, you have to do the appropriate math to make sure that you're using the correct time offset. And if this is calculated wrong, it can mean that you're recording a completely different time interval, and all the rest of the work that you've put into the project doesn't yield the results that you need. The rest of the presentation will focus on strategies for making field deployments as easy and as effective as possible. To do so, we use a variety of checklists and documents, And these might vary a bit from project to project, so these aren't things that are set in stone, but these are some of the things that we found tend to make life go easier. One is to have a packing or equipment checklist. And this can be things that you need for the deployment itself, such as batteries, coin batteries, screwdrivers, replacement straps, but it can also be things related to the site, such as gate keys or headlamps, or cell phone numbers for contact people, or permits, or various other things that are important to carry when working in a particular location, any one of which could cost you a trip either back to a vehicle or back to a central base. Deployment sheets can also be a useful way of recording details about a project. This might document recording locations, equipment settings such as gain and sampling rate, the start and stop time when recorders were placed in the field, and other critical metadata. This might not be necessary for some projects, but it's generally good practice, especially for large or complicated projects that involve many people. It provides a very easy reference if there are later questions about what the gain settings were or what day particular sites were serviced. Deployment checklists can also be a valuable strategy for ensuring that units are serviced in a consistent fashion. And so this is a checklist that people would use each time they're starting a recorder to make sure that the unit is properly programmed and equipped. So it can include things like changing the batteries, both the large batteries and the coin batteries if you're using Swift recorders, setting a schedule, making sure that the strap is not dangling in a way that might make noise in the wind, checking that the microphone is attached and has a windscreen, things like that that are relatively obvious when changing a single recorder, but if you're doing 20 or 30 units in a day, just provide a good source of consistency so that you're not later wondering whether you checked each individual element. We often use checklists as well to ensure that we're making complete voice announcements. And voice announcements are a verbal announcement at the beginning of recording when a unit is started. There are examples of all of these documents on the website. For your individual projects, you might find that some documents are more appropriate than others and that you're making new or modified versions of these. These aren't documents that are set in stone, but having some sort of documentation can be incredibly valuable to these passive acoustic monitoring projects. A large piece of executing a successful project is being very consistent across all settings, all sites, all years, and so the better the documentation is and the better the organization is, by far the better the data quality is. So why use voice announcements? There are a lot of advantages to using voice announcement. This is a vocal description that goes at the start of the recording, and perhaps the most important thing that it does is it provides a strong layer of security in the event of card confusion or file naming issues or other data ambiguities. Even if you lose the written information that's on the card or the information in the file name, at least you have hard-coded into the recording a person standing there saying, I'm at this site, it's this time, it's this year, and that gives you a really solid double check on the information that you're recording about the location and time and date when the recording was made. Some of the things that we like to include on voice announcements are the date, time, project, recording location and site, equipment ID and type, and the name of the person that's conducting the project. Some information that you might consider including are things like sampling rate, gain, sampling schedule, and perhaps even a verbal description of the habitat. So later you're not trying to remember, was this the recorder that was next to the fallen tree or the recorder that was near the road? There are some other things that you can do to optimize recording quality as well. First, beware of any elements of your deployment that can make noise. One of the greatest risk factors here is the long strap on recording units. So for example, if you buy a Swift recorder, you put the strap around the tree, but then there's all this leftover tail material that in windy sites will hang there and flap in the wind. And so instead of these nice recordings of the ambient environment, what you hear is the sound of months and months of this recorder tail flapping in the wind. And so once you pick your site, it might make sense to cut off that tail and then take a lighter and burn the ends and melt that material so that it doesn't fray, or at least wrap up the long tail and tuck it in to the strap that goes around the tree so that way you're avoiding the possibility of lots of unpleasant background noise that will influence your ability to use detectors or to visually screen those files. You can also select your site strategically to enhance recording quality. For example, many animals occur near stream beds, which makes it very tempting to put recorders right down by the stream to try to capture the activity there. But the water noise can complicate future analyses, so you might look for places where there's a stretch of still water or coming back a little ways from the stream so that you're still capturing some of the animal vocal activity, but you're not just sitting there recording stream noise for months on end. In windy areas, you can also mount recorders in locations that provide some shelter from the wind. So for example, using a hill to block some of the wind or going behind a rock outcropping so that you're not just getting the continuous force of the wind on the microphone, and it keeps that local environment a little bit quieter and makes for easier analysis. If you're attaching a recorder or a microphone to a tree, a relatively small diameter tree is actually better for preventing shadowing of high-frequency sound. It can be tempting to look for the biggest tree in a site and to strap your recorder to that tree, but actually something that's about the same diameter as the recording unit, so perhaps 10 centimeters or 6 inches, is sturdy enough to hold the recorder quite comfortably, but also allows sound from all sides to approach the microphone. And you want to choose a stable mounting location, so not a dead tree necessarily. Once you have your recorded files, there are some computer programs that can make your life a little bit easier for managing them. These programs come and go, so we'll mention just a couple of the ones that we use, and know that there are many other options that may have different strengths or weaknesses. So one of the programs that has come in handy for us is a program called Beyond Compare. And this is a program that's specially designed to facilitate file copying, synchronization, and comparison. So it will look at the copy that is, for example, on your SD card and on your hard drive and make sure that the same files are present in both places and that those files are complete, so that if you have an interrupted copying job or something that's missing, it's easy to catch that and you haven't archived an incomplete version of your data. This program allows for side-by-side folder or file comparison with verification of copies. So it's actually checking to make sure that the contents are the same size and the same composition across both versions. In addition, you can use this program on spreadsheets and look at two spreadsheets side by side and identify cells that don't match. When you get files off of a Swift recorder or other recording unit, they often contain some information about date and time, but it can be incredibly valuable to have more information in that file name. So for example, the unit number, the full date, the site where the recording was made, maybe something about the recording settings. And so we will often take the files that we retrieve from recorders and rename them with a more expanded name that makes them more readily identifiable, even if they were removed from their folder structure. Typically, the tools that are on a Windows or Mac computer aren't up to this job, but there are many third-party options available. And so if you just do a search for batch renaming, you can find a variety of options. One program that can be useful for file management is a program called Sox-o-matic. And this is something that we wrote primarily for our own internal projects, but we're making it publicly available for free as well. And it's a program that allows you to do many of the things that you might want to do when organizing your sound files. So for example, you can convert files between file types, including compressing them into a format called FLAC, which is a free lossless audio compression format that makes the files about half the size without discarding any of the original data. This can be really valuable if you're storing a lot of data. You can also change sampling rates, and you can rename audio files to include information about the site, about the date, about the type of equipment that's used. And there's a video on our website that explains how to download this program and how to use it. We found it very helpful for moving through large numbers of files that come from passive acoustic monitoring projects and organizing and curating them in a standardized way. Finally, we'll end with some practical suggestions and lessons learned. So what we did was ask our staff, what do you wish that you had known? Or what have you learned the hard way about passive acoustic monitoring? And what can we pass along to others? And these fall into a few broad categories: how to find your equipment or recorders again, how to protect it from theft and damage, some special considerations for dealing with deployments around water, bringing extra of things, we'll get back to that, and just some general tips. So in addition to deploying recorders, one of the critical pieces is refinding recorders. And this might seem easy and in fact be easy in some locations if you're deploying on fence posts or special mounting locations. But if you're just going out in the forest and putting a recorder on a tree, it can be quite difficult to find your recorder again. And so something like GPS coordinates is useful, or GPS trackers on marine equipment. But we've also found flagging tape to be quite helpful, particularly if there's one group of people deploying recorders and maybe a different group of people retrieving them. GPS coordinates can get you pretty close, but even when you're within 10 or 20 meters of a recorder, you can spend quite a bit of time looking for it, particularly if it's on another side of a tree and not directly in your line of sight. So using some of this bright colored flagging tape can give you a leg up on finding where these recorders are at. In some sites, it's important to protect equipment from theft as well. And so many recording units will have a way of putting a cable through them so that they can't be easily removed from the tree along with a lock. You can also use camouflage material to make the recorders less visible if you're in a high theft area, remembering that you will need to find the recorder. So in this case, putting out flagging tape that is perhaps 5 or 10 meters away so that you can find the approximate site and then look carefully for the camouflaged recorder. We've also sometimes had success with warning stickers on recorders. So for example, putting a sticker that says high voltage or high voltage keep away can deter the casually curious who might be inclined to tinker a bit with the unit. In some parts of the world, it can be a bit of a sport to shoot at road signs or unidentified equipment. A tip that was shared with us by an undisclosed government agency is that in this situation, putting a national flag sticker or a state flag sticker on the equipment actually makes it substantially less likely to be vandalized or damaged or shot. Many deployments happen on the edge of bodies of water, and just a reminder for you or field teams that are working in this environment, especially if people are out alone, is that water can pose a special risk. Especially in ponds and swamps and marshes, water can look quite shallow. And then once you step into it, it turns out to be quite deep. Especially if you're wearing a backpack that has lots of batteries and recorders, it can actually turn into a dangerous situation. This is especially true if you're ever out in chest waders. So in this case, if you're wearing chest waders and they fill up with water, it can make it very difficult to get out. So one of the safety precautions for chest waders is always to make sure that you have a belt around them so that they can't take on too much water to prevent you from getting up, especially with a backpack full of acoustic equipment. Finally, perhaps one of the most important parts of this presentation is to bring extra. And so this can start at a very introductory level. Bring extra windscreens. Insects love to eat them. Small rodents love to eat them. They get lost, they get damaged. I've been involved in deployments where we've replaced every single windscreen, but sometimes it goes beyond windscreens. Microphones wear out through time. Every few years, you probably want to replace your microphones anyway, but sometimes more dramatic things happen to them. So for example, this is a microphone that was casually munched by a bear, and you can see in the upper right corner the claw marks left by the bear on the recording unit. So the recording unit still works, but the microphone is probably unlikely to record again. And so having a replacement allows you to immediately put that unit back in service rather than walking back to the vehicle, in the best case scenario, to get an additional microphone, or perhaps going back to your lab, ordering one, and then having a unit that started at a different time than the others in the deployment. Likewise, it's useful to have extra SD cards in case one of them isn't reading or gets dropped in a mud puddle. Extra batteries, and also if you're using a tablet or something like that to program in the field, having a backup tablet in case the battery dies or something happens to the tablet, such as getting dropped and cracked. Bringing an extra screwdriver, because at least with Swift recorders, they open with screwdrivers, and nothing shuts down a recording project in a faster and more frustrating way than being out there and trying to find the perfect shape rock or stick to try to open the recording unit so that you don't have to hike miles or kilometers back to your vehicle to get another screwdriver because you dropped it in the leaves at the last site and you can't find it. And it doesn't end there. You might actually want to bring extra recorders. So going back to the previous suggestion of not deploying a recorder on a rotten tree, even in the best case scenario, trees sometimes fall or branches break, and there can be damage to the full recording unit. You might find that the seal was compromised and the unit is full of water. So in the end, you actually want to really be bringing extra of just about anything and everything. And you might assume that this isn't going to happen to you that often. I should note that all of these pictures actually come from the same project, so this isn't even collected across many different projects for many different years. When we asked our staff what they wish they knew or have learned through time, one person replied, spares, spares, spares. Besides windscreens and microphones, I always have a spare screwdriver, a spare USB cable, and spare SD card in my backpack. A different person answered that it's always a good idea to check the voltages of your batteries, or carry a spare set with you. I've loaded new batteries into a Swift and then found one of them to be dead. It might be a rare occurrence, but you don't want to hike a long way to your site and then not have enough batteries. If you're conducting a remote deployment, for example, on a site that's hard to get access to or that you might not visit again until the end of the season, it likely makes sense to prepare 2 or 3 additional units using the same settings, the same cards, battery, announcement, etc. And that allows you to deploy these units in your backyard or in some accessible location, even a cupboard in your lab. And that way, after a few days, you can go and check on one of the units to make sure that it's recording the schedule and sampling rate that you had planned. In passive acoustic monitoring, a relatively small error in setting up equipment can have huge and devastating consequences. For example, if you're recording in the evening instead of in the morning, or if you are recording continuously and the recorders die within a few weeks rather than recording on a schedule throughout the season. This can be especially important for things like graduate research projects, where you might only have 2 or 3 or 4 field seasons in which to get data. If a scheduling error or other deployment issue keeps you from getting data in 1 year, that can have really dramatic consequences. And so in that case, it makes sense to buy yourself the insurance of having a unit that you can actually watch and make sure it's doing what you think it's doing. That gives you higher confidence that the units out in the field are also doing that thing. If you have 2 or 3 of these units, you can examine one to make sure that the schedule is running in the way that you think it is, and allow the others to keep running, and that way you can keep an eye on the warning lights in case the battery runs low or the cards get full earlier than you had anticipated. That allows you to look at your local unit and know that you'll need to do something with your field units in order to get the data that you need for your project.